All right. Hello, Los Angeles. My name is Deepak. If you're on channel Puppet on Freenode, I'm Giridharagopal. Also on Steam, if anybody wants to shoot some zombies later. And like Daniel, I'm one of the lead engineers at Puppet Lab. So today I'm going to be talking about PuppetDB, which, as we mentioned earlier, was just released yesterday. It is open source, and I'll be talking about higher order Puppet using PuppetDB, which I will explain in a second. So this whole talk is going to be about data. Big data, like big data. And in particular, the particular aspect of it that I want to talk about is that, contrary to a lot of, people have scripts, people do things manually, one of the advantages of using Puppet is that it has a lot of intelligence about, how you want your systems to look, and how Puppet itself, is operating. And at the end of the day, we generate just a shitload of data. And there's all kinds. It's data, some of which we persist. A lot of the data is completely ephemeral and we just throw away. A lot of the data lives local to a particular machine, like every agent. A lot of the data lives on the actual Puppet master itself. Some of it is totally freeform, like random statements and log files, random reports where it's just English sentences, and a lot of it is actually structured. And there's just a ton of it. So I'm going to go through a couple of different types of data that Puppet actually stores, just to give you guys some examples. So catalogs is the big one. And when I say catalogs, what I mean specifically is the catalog represents the set of things that you are managing for a particular machine, right? So every host, and Puppet basically compiles, it takes all of your .pp files and all of your Puppet code for a particular node, and then it compiles a catalog, which then gets shipped to the agent, and the agent evaluates it. And whenever you hear any of us talking about like the graph, Puppet has a graph. It's not like x-axis, y-axis kind of thing, but it's circles connected to each other with arrows. And that basically represents every single resource that Puppet is managing on that machine. And every arrow is like all the dependencies. Like this file depends on this package, depends on this service, depends on this class of other things that need to be applied. So under the hood, what Puppet is doing is it does a lot of graph evaluation, where it walks that graph to figure out what order do I need to do things and why. What parts of the graph are disconnected, so if one thing fails, I can continue to evaluate the other part of it. And that graph contains everything that you have in your Puppet code. It has all the containment relationships. Like I've got this Puppet class, and then inside of it, I've got like 3 files. Like the graph knows that these 3 files are inside this class. Dependency information, like I already mentioned. Every single class that you have, all the tags that you have on every single resource, every resource parameter, and all the metadata that you can possibly have all ends up in this catalog. So what ends up happening is you have code that looks like this, which is I have a file /temp/foo, and I want the file content to be this is the test. And under the hood, what that's going to generate is apparently not on the screen. So let me try that again.
When you have the display up, yeah, like 540.
Let me see. What is the actual?
Try the 720p.
I think someone was at 1080 earlier. Display.
Good enough. One second. Man, so many technical difficulties. Computers. Aha! Much better. Okay, so that code ends up generating this snippet of stuff that ends up in the catalog. The catalog is meant to be machine readable, so this is kind of strange to actually look at. But basically, you can see that this is the file in which I defined, that source code up there, what line number it was on, and you can see that all the parameters to that thing. I have content, which is this is a test. That's the resource reference you have here, and you have all this other information, all these tags, the title, it's a file, temp foo. So you got all this information, it's all machine readable, and that's all great. A picture of the graph is something like this. And actually, this is a lie, because this is just a cut and pasted snippet of a really big resource graph. So if you install like Puppet Enterprise, for example, if you take the demo VM, which is exactly what I did, and you do nothing else other than install it, this is all the stuff it's configuring on the system. So basically, this is the resource graph for setting up Puppet itself. So there's a lot of stuff going on in here, right? Even though you only end up writing a couple of snippets of Puppet code. But because this is really hard to see, if we zoom in. So for example, this is setting up the Puppet Enterprise user that Puppet runs under. So you've got like, I need to create a group, and then I need to create the user who belongs to that group. So obviously the group needs to exist first. Then I create some files, and the files need that user to exist because the user has to own a file, right? So you can't do chown unless the user is actually there. And other sort of stuff. So, that's nice. But it's a lot of information, right? And it's useful information to, maybe you want to query this, maybe you want to do operations like, I just want to know all of the groups, or maybe I want to know all of the users that I have on a particular system. Like, that's kind of nice. That's catalogs. Facts is basically everything that we detect by when the agent executes factor. So factor is one of the complementary tools to Puppet. Puppet requires it. And it's basically a library that does interrogation of a local system to give you facts about the system. So that's what kind of hardware it's running on, what kind of OS, network info, IP addresses, and you could write custom facts. And the idea of using factor is that when you write Puppet code, let's say that I want to write the configuration for a machine and I want to spit out a config file. But that config file needs the hostname of the machine in it. That's not something you can do by shipping a static file to every node, because the hostname is not the same across every node, right? So if you can refer to a fact like $hostname or something in your templates for these config files, then that problem goes away. And that's what facts are for. And as Daniel mentioned, coming soon is going to be structured facts. So instead of a fact just being a string, you can actually have a fact that's a list of things, a list of network interfaces. Or each network interface has attributes, like this is my net mask, IP address, like that kind of stuff. I ran factor on a VM and got just a ton of stuff. But this is just an example of all the data that is available to you as you write your Puppet code. And more importantly, it's data that exists in the Puppet ecosystem. Like, all these machines have all these facts, and wouldn't it be awesome if we could correlate them and do interesting things? We have reports. So catalogs say what you want a machine to look like. You specify the config, this is how I want you to look. A report says what you actually got when Puppet ran. So one is the desired state, and then one is the actual state. So for example, if Puppet had a problem executing one of the commands you told it to do, that's going to show up in the report. Catalog doesn't care, because the catalog says what you want to have happen. So one represents like reality, and one represents utopia. And obviously, you want the two of them to be one and the same. Heaven is a place on earth. And there's a lot of interesting information inside of reports as well. Again, this is meant to be machine readable, but for the exact same file, temp foo, this is taken out of a report. But you have information like evaluation time, which is how long it took Puppet to actually make this file look the way that I told it to do it. And a bunch of other stuff. I didn't have an error, failed as false. I had to actually make modifications to this file, which is why autosync is true, and things like that. So anyway, there's a ton of information that we have floating around. So imagine all of that stuff going around for every single host, every single time Puppet runs, if you run it every 30 minutes or something like that. It's a lot of information. So that's all great, but who gives a shit? I truly believe that more information at an operator's disposal is better. Full stop. There's this movie that sadly now is kind of an old movie called Sneakers. And there's this awesome scene between Ben Kingsley and Robert Redford where he says that there's a war out there, old friend. It's a world war. And it's not about who's got the most bullets. It's about who controls the information. And I thought that was awesome. Because, the point that he's trying to make in the movie is, it's all about the MacGuffin is this magical device that decrypts like anything. This movie was like in 1992, so, it's kind of awesome in that way. And his whole point was like, I don't need bombs, I don't need anything. I can wield the maximum amount of power possible if I have access to all the information that I want. And I think there's a lot of truth to that. The flip side is he plays the egomaniacal, like, supervillain in the movie. But, glass is half empty, glass is half full. I think he had a point, which is information is very powerful. And one of the most easy ways, I think, within Puppet to take advantage of information that you have, contrary to writing, a bash script or something like that, is through use of facilities that Puppet gives you to exchange information and do kind of higher level things. So a number of people today have talked about store configs, but at its core, store configs is about centralizing the storage of the configuration of every single node that you've got. Like that's basically all it does. So if you have 1,000 nodes and you have catalogs if you have 1,000 nodes, Puppet has 1,000 catalogs. And wouldn't it be awesome if all those catalogs were stored in one central spot? It was all correlated together. You could query it. You could do interesting things with it. That's pretty nice. And in the database, by default anyway, you get everything in the catalog. It's every single resource, every single parameter, all the classes, all the stages, anything that you have in your catalog ends up in the store configs database. And what this lets you do is use a Puppet feature called exported resources, which is what we've talked about before. And this is an example of code that uses exported resources. This is actually taken from one of our longtime contributors, Brees. He's Master Zen on the Puppet channel and on the mailing list and such. But say, for example, that I just want to have something. So, okay, I declare a class called exporter. And what that's going to have is that's going to have a file, varlib puppet nodes, and then the name of that file actually varies depending on the fully qualified domain name of the host. But the content of that file is just going to be the host IP address. And then that resource I give a tag. So on any node that I apply that class on, there's a resource in that catalog with a tag of IP. And the double @ sign means that I want this to be exported. So store this centrally somewhere. And then I have a couple of nodes. So, we'll have one node, export 1, that's going to include that above. I'll have node 2 that does the exact same thing. So that's all great, but what do I actually do with it? So I can have a node that collects all this information. And what I could say is basically on this collector box, find all the resources from anywhere, all the file resources from any other node that has this tag, and then basically apply those resources to the local machine. And right there, that's an example of individual nodes kind of export information about themselves that some central box uses to configure itself. And this is a contrived example, but there are plenty of non-contrived examples, right? Like we talked about before, things like distribution of public keys. Individual hosts may have public keys that they generate, but you want to distribute that to every other host, or a central set of hosts that you want people to log in from, or something like that. Monitoring checks, that's one that we've been hammering on. Like if I write code to set up a web server, for example, it's a waste of time to have to manually log into a Nagio server or something like that in order to say, oh, I have a new web server. Let me log in, do some typing. That's dumb. Seriously. So what you should do instead is, in your monitoring server, in the Puppet code that sets it up, just say, find me all the services, running anywhere, or find me all the monitoring checks that have exported from these machines, and then realize them locally. So that way I can have the configuration of my monitoring server be driven by the rest of my infrastructure. Any kind of clustered service, this would be really useful, because most clustered services, you need to know about membership of the cluster to configure the cluster itself. Right? Like people that belong in a pool of things that do something. You generally need to know the addresses of everybody else in the pool, assuming you're not using multicast or something like that, or even authentication credentials between them. Any kind of replication scenario that you have, the master needs to know who the slave is, the slave needs to know who the master is. They both need to know what ports do I need to have open. There's a lot of information that needs to be exchanged there. We already talked about load balancers, things like shared file systems. If I had an application server that needs to use an NFS mount, I could export, the requirement of those NFS mounts, and then on my file server, I could realize them all, so I only expose mounts to the people that actually need them. So, these are all examples of things where anytime you want to configure one node based on information from other nodes, that's when this feature becomes really, really useful. And then, the corollary to this is just storing that information isn't particularly useful unless you can actually query it. And the nice thing about a system, if we could provide a good query facility for all the information that we've already got, then that lets you do pretty interesting things. If I have all the resources for my entire population stored centrally somewhere, then I can interrogate it, I can correlate it with other data from some external system. I could use it in scripts or something like that. And I think that would be really cool. So the point I'm trying to make is that I think this is what I like to call higher order Puppet. When I say higher order Puppet, I mean that you use information within Puppet to drive Puppet's configuration of other boxes. You use your infrastructure, you use the configuration of your infrastructure to configure your infrastructure. And I think that's an amazing, I think it's beautiful in that it's a simple statement, but it belies a really large amount of power, I think. It's very different than if you just go to individual nodes and configure them a certain way. If now you can use the smarts about your entire cluster of nodes, your entire population of systems to configure things, then I think you're kind of cooking with gas. So the problem with all this is volume, right? So like I said, every single node on every single Puppet run generates all kinds of data. So for example, we have a customer that generates over we did some measurements. They generate over 750 gigs. Their Puppet infrastructure generates about 750 gigs a day. Not all of that is getting stored. Not all of that is, useful to them. But that's the raw material that, in theory, we could smelt into something awesome, right? And even if you take a really small percentage of that data, even 1% of that is still ridiculous, right? And if you think about it, if you have a 30-minute run interval and you have like 1,800 hosts, that's one host checking in on average every second. And every time that's checking in, we have a catalog generated by the master. We have facts that have been aggregated. We have all kinds of crazy stuff. So it ends up adding up to a lot. And whenever I explain this to people, I think a lot of eyes glaze over due to math. And you have to do long division to figure out well, if my Puppet's running every so many minutes, and then so I have made an attempt to try and make this more obvious.
No math.
With no math. So let me get a web browser up. Whoa. That did not do what I wanted to do, but close enough. Alright. Okay. So this is a simulation sped up by about 5x real time, where each circle that appears represents a host checking in with the Puppet Master. So I'll explain the color coding as we go on. So red, little red dot shows up. That's basically I have started my process. I got some facts. That takes a certain amount of time. The model says that that takes about a second or something like that to collect all your facts. The amount of time it takes to turn orange is a function of how long it takes the Puppet Master to compile the configuration for one of those hosts. So I'm randomly picking, a number of resources between 500 and 1,000 is what I have it set to. That's why some of these circles are bigger, some of them are smaller. The radius is a measure of how complicated the config is on a particular host. And the bigger the circle, the longer it takes, because that sort of makes sense. The bigger your resource graph, the longer it's going to take for Puppet to actually do anything interesting. When stuff turns blue, that means that Puppet is now ready to persist all that information in a database. So store configs is happening. I'm actually going to store some stuff. And I put in some basic numbers on our own benchmarking at about 10 milliseconds per resource that you want to store. So obviously this is to scale, but it stays blue for about as long as it takes for your database to end up persisting all of this stuff. And as you can see, as more large things check in at right around the same time, stuff starts to slow down. So that's all great, but that's 100 hosts. So let's say that instead I want to do 200 hosts. Let's see what happens. So this, in theory, should start seeing, you get stuff way more often. Actually, what I'm going to do is speed this up maybe 10x. I don't even know that I have to. So one of the points I'm trying to make is things start to back up. So the way to think about it is this screen represents your Puppet Master, right? And every time you see a circle on the screen, that means one of the threads on your Puppet Master, one of your cores is tied up, doing something. It's either receiving facts, it's either compiling a catalog, it's either sending some information off to a database in order to get stored. And the more of these circles that are present, they start to back up. And then what happens is it takes longer and longer and longer. Like imagine that I had 1,800 hosts. 1 per second, hitting my database server, trying to store all these resources that I've got, eventually things start to back up. So from when we started this to now, this is sped up 5x for 200 hosts. It hasn't even been more than 60 seconds. And you could already see, like, a lot of this stuff is not going away anymore. This is based on the theory that your database is not going to scale linearly, right? If I have one thing trying to store a whole catalog's worth of information in my database, then if I have two, the second insert isn't going to go as fast as the first one because the first one is still going. If I have 3 going on simultaneously, that's even worse. And there's a point of diminishing returns, right, with any kind of database. Eventually you'll just get completely disk bound and, your shit's all ruined.
Yeah, you're blocking out little fact things where they were just...
Yeah. So now, these guys who are waiting to compile, I put into the model that the time it takes to compile is also based on the current backlog of existing things that are waiting to be compiled. So now you end up with, like, essentially, I can't do anything. I have to turn everything off and wait for it to drain. So that was with 200 hosts. So at my last job, we had about, maybe 5,000 hosts on a 30-minute run interval. Oh, I'm screwed. And one of the things you could do is you could be like, oh, I know what I'll do. I'll just make, like, 1,000 Puppet Masters or something like that just to deal with this. Or I'll get a database that has ridiculous I/O or something like that in it. I was talking with someone in Puppet Labs, and they were mentioning that we have a customer, and they use FurConfigs, and they ended up buying, like, they had a RAID 10 array of Fusion I/O cards for their FurConfigs interface.
Oh, man.
And I know the guys from Fusion I/O, so that gear is really good, but I'm pretty sure one of those cards costs like 10 grand. So it's a lot of MP3s. It's a lot of, that kind of stuff. So in theory, let's say that I could actually get store configs to run pretty quickly. So I think I'm doing this right. So I'm going to drop the store configs delay to, instead of being 10 milliseconds per resource, to be, say, 0.1. And then I will convince you in the rest of the talk that I have made this possible. I actually haven't tried this, so I don't know what's going to happen. This is not too bad. This is with the same number of hosts. So if you can decrease the amount of time you're spending doing the slowest part of the entire operation, then your throughput will eventually be considerably better. So I mean, even though there's a lot of shit going on the screen at the same time, this is a demonstrably better situation, I think, to be in than where you were at before, when things took a really, really, really long time.
What did you do to make the difference?
What was that?
So what did you do to make these two different? Make it go faster?
Well, I can show you. So, sorry, probably can't see it super well, but this is the actual code. So what I did was I said the compilation delay is no longer blocked by store configs, and we'll talk about how we make that possible. And the store configs delay is no longer based on the square of the current backlog divided by a constant factor. So if I can make those two things happen, if I can basically say that compilation is no longer bound by the time it takes to persist all this information, and number two, the time it takes to persist this information is actually way the fuck faster than it was before, then I can make that diagram reality. That is what I posit. So that's all awesome, but that really doesn't mean anything until I can make that actually happen. So hopefully you get my point that when the stuff is slow, it makes me cry. And it generally is a sluggish force on the entire system that you've got. Catalog compilation is slow. Your Puppet Masters will get saturated more quickly. It'll thrash your disk. And in general, it's a lot of bad news. So that's performance is important. I think another limitation of the current stuff that we've got prior to PuppetDB is that the APIs that you have to actually look at all the catalogs and all the facts that you've stored is reasonably limited, right? Like on store configs, we store all the resources you have, but there's really no supported way to say, query those resources short of writing some SQL, which is stupid. Like, I mean, I understand that people have to do it, and I myself have written code in my previous job that did the exact same thing, but that's a failing in the feature, right, that you have to do that. Like, you shouldn't have to write a lot of low-level code. Plus, it makes it harder for us as developers because we can't iterate on that code because it's going to break a lot of custom SQL that people have written. So I think ultimately we need, better ways of searching and filtering a lot of this data. So I think this presents a very interesting paradox, I think, which is that on the one hand, we want to store as much information as we possibly can, and we want to allow it to be much more queryable than the current ways in which we're storing all this information. On the flip side, we actually don't want that to slow anything down, so we want to do way more work in less time, and we need it to be reliable, because if I'm going to let people query all this stuff, and I'm going to let people store everything centrally, then that can't go down, right? So that has to be impressive. So what I think we need is essentially, like, we need a clearinghouse, right? We need some kind of central daemon of some sort that's basically the information clearinghouse, the data warehouse for all the stuff that Puppet generates, right? Something that involves the Puppet data library, which is like all of the hooks and extension points and all the APIs that we present to operators, to developers, so that they could leverage the information about their infrastructure to do interesting things. It's a hard problem. Okay, so in order to deal with this, we built PuppetDB, and by we I mean myself, Daniel Bittman helped out a lot, and Nick Lewis, who's NLU and LEW on the IRC channel. A lot of people ask me what DB stands for. It's definitely better. Definitely. From previous conversations that the company has had about this project until we named it PuppetDB, you may have heard references to Project Grayskull, which was the name that we had given it internally. This makes me feel old, but the cartoon He-Man, does anybody here know what that is other than me? Okay, all right. So Nick, who works with me, he's like recently out of college, and I was trying to explain to him. He's like, "Why is it called Project Grayskull?" And I was like, "Oh, well, there's this awesome cartoon, He-Man, and he says, 'By the power of Grayskull,' and he holds his sword up, and he's like, 'I don't know what the hell you're talking about.'" I was like, "Are you 12 years old?" So anyway, Grayskull is now PuppetDB. So ignore anything you've heard about Grayskull from this point on, and make a mental note. So PuppetDB is a couple of things. Number one is it is a fast replacement for the current way in which we store catalogs, and the way in which we store current facts. If you're already using store configs, or if you're using the Puppet inventory service, like you're using Dashboard or something like that, which uses inventory service under the hood, it is 100% compatible. It actually implements a superset of those APIs. But if you have any existing code that uses store configs whatsoever, barring, of course, scripts you wrote that dig into a database, all bets are off there. But any Puppet code that you have that collects resources and things like that, that'll all continue to work 100%. And we actually tested that because we use internally for PuppetLabs.com, like our intranet and our website, we use Puppet, of course, to manage all of our own stuff, and we use store configs for everything, and we rolled this out internally like a couple of months ago. So, it works for us. It works on my laptop. And the last part of it is that we have genuine, documented version proper APIs for querying resources, querying facts, querying node status, all kinds of stuff, and even other things. And we do this using a combination of science and secret alien technology, which I could talk about. So these diagrams are like super boring, but I figure it's a useful thing to at least give you a high-level view of the major components of PuppetDB, but there's a message queue, which I will talk about. But we use that to basically apply, to insulate certain aspects of PuppetDB from back pressure from others. Usually if you have a problem where it's like, I need to do like 12 steps in order to make something happen, but step 3 may be really slow, or step 8 can be really slow, you insert a queue in the middle, and then now you have a place for back pressure to apply. We have command handlers that basically take in all incoming data, like new catalog, new facts. And we take those wire formats, we do a lot of slicing and dicing, we do a lot of validation to make sure that they're legitimate, and those get persisted. And then all queries come in over a REST interface. So because that diagram sucks, I figured that I would try something different. So this is an example of what the workflow looks like if I have an agent, and I have a master, and I have a PuppetDB server, and I want to actually get my information persisted in PuppetDB. So this is the storage side. So agent, master, PuppetDB server, those are all the different components. I'll talk about what DLO is in a little bit. But the PuppetDB server, you have a database, you have various workers that are pulling things off of an MQ, and then you have a web server. The agent currently doesn't have anything in it. The master, these basically represent these different extension points or terminuses inside the master. But it's basically like encapsulated logic for dealing with facts, for dealing with catalogs, and for dealing with resources. So if we start off, F represents facts. So the first thing that happens is an agent, you do Puppet agent, -T or something like that. Basically, you trigger an agent run. First thing that's going to happen is it's going to say, okay, well, I'm going to run factor on my local system to get all the facts about everything going on, and I'm going to send that to the master. The reason why the agent needs to do that is because you could have code, Puppet code, on the master that depends on certain aspects of the host you're trying to configure. Its host name, its IP address, things like that. So the first thing that's going to happen is facts get reported over to the master, which is kind of nice. So once the master has all the facts that it needs, what does it do with them? We can do a couple of things. Number one is now that it has all the facts about the node, it can actually generate a catalog for that node because I have all the information that I need. Simultaneously to that, I can actually farm off a copy of those facts to the PuppetDB server. And that goes in via HTTP. It's actually HTTPS, but it is secured communication, but I figured it's one less letter. I'm pretty sure Apple licenses this to mean by the letter. So the next thing we do is once we have the catalog, I can spin off a copy of the catalog and send that over to PuppetDB via HTTP. And then what happens is the web server actually just spools this to an internal message queue. So now inside PuppetDB, I have here's a pending set of facts that I need to store. And then things sort of move through the pipeline. Now that the master has a fully formed catalog that it can give to the agent, I can send that back to the agent. The agent can do its thing because it now has all the information it needs to configure itself. And in the meantime, one of the workers will pick up the latest set of facts from the message queue. From that point on, the worker is responsible for actually making sure that that information is persisted. Nothing else is happening on the agent because the agent's basically done. Once the agent gets its catalog, it's really just executing Puppet, locally at that point. And then once the workers chew through the backlog, we have a database that has the facts. It has the catalog for that particular agent. Some of the nice things to notice about that is the agent actually can get back its facts, and it can get back, or the agent gets back its catalog, even though that catalog has yet to be persisted. So that is a way in which we can decouple the persistence of a lot of that information from the compilation process itself. Yes?
So how many workers you have, for example?
By default, if you install PuppetDB, we inspect the number of cores available on your system and divide it by 2. So if you have an 8-core box, then we'll use 4 CPUs, 4 dedicated worker threads. It's configurable.
So if you want to expand it, you use a 16-core machine.
Well, if you just install it on a 16-core machine, it'll automatically use 8 cores.
So you're limited by the number of cores like that.
Well, you're always limited by the number of cores, right? That's physics.
He said it's configurable.
It is configurable. I mean, if you want to use all 16, you can. I find that the PuppetDB server isn't only running workers. It's also running other stuff. It also has an internal MQ. It also has an embedded web server. It also has other things going on. So dedicating all of your CPU to just the workers can actually end up hurting your throughput over time.
Can you have multiple PuppetDB servers talking to a central database?
Yes.
So you can have scaled out and workers.
Yeah, yeah.
And queues.
Yeah, you can.
Then you
There's
have
some limitations there, but
who update the same data.
yeah. For now, I would say that it's mostly meant, I think if you were to do that, you would probably need, you would have to have a lot of hosts, I think, in order to make that necessary for performance. But for HA, there's no reason why you just can't have a second one and you just don't send anything to it. You can use, DNS.
You make sure that no 2 hosts update the same at the same time. If you have
No, this is a distributed system, man. I mean, all bets are off, right? Like,
Oh, yeah,
you
even
can't
the codes
assume,
are distributed.
with any distributed system, you can't assume that things will ever execute in the order in which you ideally assume they're going to execute, right? Because it's never, there's always going to be some weird glitch in the matrix or something that ends up, for some reason, one agent sends its catalog and then it's just like trapped in the jello of your Ethernet or something like that. And then, or maybe someone tells Puppet to run twice in a loop or something like that, and you get 2 catalogs for the same host back to back. So actually what we do is all the workers, as we pull these items off, it's all item potent. So if you say store this catalog, Every catalog has a timestamp associated with it. So if I've already stored one that's newer, then I don't need to store one that's older if I get it later, for example.
So
Or if I get the same one, it's not a big deal.
So it's okay to be out of order.
Yeah, in fact, you have my statement is that you have no choice but to assume it can be out of order. Because anytime you have more than one host involved in anything, you can't assume that ordering is going to work all the time. And if you can't assume ordering is going to work all the time, then you may as well design your system to assume that's going to happen, assume shit's going to happen from the start. Because if you don't, it will, and then you'll be sad. Yes, sir?
The architecture of this so far seems very similar to Puppet Dashboard. Is it built on the same?
It is not built on Puppet Dashboard at all. I'm convinced Puppet Dashboard would not be fast enough for any of this. It's actually a fairly different technology stack that is very, to the point of the last presentation, this is entirely specialized for this exact problem. Whereas Puppet Dashboard is entirely specialized for a very different kind of thing. Like currently, for example, and I would argue that it's not super well specialized for the things that it does, just because we haven't put as much effort into it as we need to. But this is purpose-built for this kind of stuff. So like the databases we choose to use, the entire technology stack that we choose to use is chosen specifically for things like safe parallel operation, high throughput, the ability to multiplex actual operating system threads over how many cores that you have. We do a lot of that work on our end. I'll talk more about that, I think, as we go on. Yes, sir?
I'm not sure if you're done with your, this.
I have more, but
No, I mean, this.
This is done. This is done.
Okay. So, what about results?
Aha. Collection. I love it when a plan comes together.
I'll give you that $5 after we're done.
He's a plant. All right, so collection is the query side of this. So that just showed how I actually export the information. But in the exported resources example I showed you before, where I had...
What I was getting at was, so the agent compiles or executes the catalog
Yeah.
and applies it to a system.
Yes.
There's going to be results from that. Is PuppetDB
Reports.
handling any of that
Oh,
stuff? Or
no,
is that
no, okay, that is a good question. So in the beginning, I talked about reports as being one of the big sources of data. The current version of PuppetDB that we just released does not handle report storage, but it will handle report storage once, that's on my roadmap.
Okay, right.
So ultimately, at the end of the day, I want this to be storing like all of the auto-generated data.
At scale.
Yes.
So that's why you're doing
That's my mission.
partial implementation.
Yeah.
To get the good stuff.
Yeah, I mean, report storage is hard. I mean, that's a hard problem just because it's a lot of it. Once you get into historical data, that adds like a really tough, like kind of scalability dimension to this, where
And all the crazy stuff you want to do.
yeah, and there are approaches to that we've talked about, but my theory was I'm going to pick off certain subsets of this data and then make that work and then ship that to people. But it's coming.
And so to the previous question, this does look kind of similar to Dashboard. What you'll probably see is that as this matures, Dashboard will move to using PuppetDB rather than implementing the same sort of storage techniques poorly.
Yeah.
So the goal is to take advantage of this, to unify them. You're quite right, they are similar things, trying to do a similar job. This one is much better. We'll use that one instead.
And for example, the current dashboard uses the existing Puppet inventory service API in order to let you query for facts and query for nodes. So PuppetDB is a complete inventory service API. It implements that API. So actually, if you just configure your Puppet master in puppet.conf, you just set the inventory, the facts terminus is what it's called under the hood, to this instead of what it does by default, then you could use the exact same dashboard, only all of your fact and node queries go to this. But dashboard doesn't need to know. It won't know, and it won't care. So, in that extent that, so for things where dashboard is already using a properly abstracted API, it's easy to slot this stuff in, and no one, none the wiser. But that's not everything that dashboard does. Okay, so collection. I have an agent, again. He generates a set of facts. Okay, that's great. The problem, though, is that let's say that I wanted, the configuration of this agent depends on the configuration of other hosts that I have. So what the master has to do is it has to make a query to actually figure out the to say, let's say the agent says, I need to know all of the Apache web servers or something like that in order to configure myself. So the master doesn't have that information locally. It has to make a request. So I can generate that request, and I can, by the way, also simultaneously send the fax over to be stored. So the query goes in via HTTP, which is nice. The fax lifecycle is going to be the same as what you saw before. I can hit the database, I get my response back, which I send back to the master. Now that I have my results, I can turn that into an actual catalog, which I can then send over via HTTP, and then I can send that to the agent. The agent can now execute, and now the catalog can go ahead and get persisted the way that it always would. So the compiler is blocked depending on how quickly it can query those resources, because you need to query those resources to generate the catalog, right? So that's something that can't be decoupled. That is a synchronous operation. And in fact, if PuppetDB is down, for example, like that will fail. But I think that's what you want. You don't want to send your agents back a config that has incomplete information or wrong information in it, right? So, I think that's a reasonable failure model to actually have. On the subject of failure, oh yes.
I noticed that you're storing the fax again in a different operation. Are you doing some kind of dedupe, and so just storing different facts that have dealt it, so you're not storing the full fax every time?
We actually do store the full fax every time. Dedupe is something that is on the roadmap, but the reason why we didn't do it is because compared to catalogs, the size of a fax set is actually really, really tiny.
Right.
So, yeah. But that is an entirely legitimate optimization to do. It wasn't as high priority as some of the other optimizations that I'll talk about.
I'd actually phrase that as might be worth doing. One of the awesome things about deduplication is it requires reading a lot of data to see if it's already present or otherwise tracking if it exists. And that can be surprisingly costly compared to just streaming write.
Yeah,
So in a bunch of these cases, it is more efficient not to deduplicate.
Yeah, like if you have a database whose table storage is like MVCC, which is like a concurrent way of doing concurrent writes to a database, then it's actually really easy to just say, delete all the old rows for something. That actually doesn't result in a bajillion writes. It actually just results in changes to some statistics tables inside the database. And it'll clean up those rows later, but it won't return them in a query. And then, here, let me stream to you, maybe a couple of hundred rows? A couple of hundred pieces of fact information? So, at the end of the day, that's not a huge deal, I think. Which is why
I just meant to bring it up because I was going to ask about catalogs.
Yeah.
Possibly
Catalogs are the big one, so I'll definitely talk about that.
Your general storage mechanism.
Yep. So failure. Things will go wrong, so what do? Agent has its fact. Agent sends facts over to the master. Facts go over here. This is all looking really familiar to you guys, hopefully, at this point. The worker picks up the set of facts. There's a problem, though, in that, maybe the database was down, or maybe the fact payload that I got was malformed or something like that, or there's just some weird shit in it, or I coded up a bug and I can't store that set of facts. That actually just gets bounced back onto the message queue. I'll talk about that in a second. A worker will, again, eventually pick that up, and maybe it may fail again. It'll bounce it back. And it will keep doing this, n times. N is actually currently not configurable, but basically the approach that I took was kind of like how a mailer daemon would do things. I tried to actually relay this email message to somebody, but for some reason the server that I'm supposed to talk to isn't up. So what do? I don't immediately bounce it. That's kind of horrible, because again, failures happen on the internet, right? But instead what I'll do is I'll do like exponential backoff. Like I'll send another copy of that like 1 second from now. Oh, that failed. Then okay, 2 seconds, 4 seconds, 8 seconds. So we actually do the exact same algorithm. We actually just do 16, we square the previous one, 16 times. So I think the maximal wait is like 18 hours or something like that. But we'll keep trying. And that actually, it's persisted. The MQ is persistent. So even if you take PuppetDB down for maintenance or something like that, if you bring it back up, it'll pick up exactly where it left off, continuing to retry. So actually you can do interesting things like take down the database or something like that. And all the things will just continue to queue up. It'll be fine. That was a key thing, one of the feedback from our internal operations staff when we were building this, is they're like, dude, I have to be able to do maintenance on various aspects of this without hosing the entire system. So make that happen. It's like, okay. After a certain amount of failures, instead of just like, logging an error message or something like that, I think that kind of sucks. This was a British error. Like, I hated that. So instead, we actually put it in a directory on the file system that we call lovingly the dead letter office. And the dead letter office, like the post office, is like if they can't send mail to wherever you want it to go, and they can't even bounce it back to you. Maybe then they'll, so letters to Santa and stuff like that. If he wasn't real, would end up in the dead letter. I don't want to ruin anything. So the dead letter office actually, one of the things that we did was I was like, okay, well, this space is kind of cheap for failure. So what we'll actually do is we'll just store bit for bit the exact payload that came in. And we will also instrument it bit for bit with every single exception that we encountered for all 16 times, with full stack traces of everything. And then we'll just give people easy tools to let them just reprocess it. And the reason why I wanted to do that was purely for selfish reasons. So that way if a user or something has some problems and they're like, this couldn't be parsed, or I had some error and this just failed, I could actually just tell them to send that to me or something, or scrub, you run it, it's plain text. So you just scrub it with, sed or something if you want, and then send me the info, or at least just send me the exceptions. But that way, as a developer, I can get the exact thing that caused you problems, and then I could replay it if I want, and then see what horrible things happen, and I can actually fix your stuff. That would be kind of cool.
And then if it's a problem with the worker, you update the worker,
yeah,
replay it.
Absolutely. And I don't have any slides for this, but there actually is a way, if you restart PuppetDB and give it a particular flag, you can connect to it on a port that's bound to localhost, and you could actually redefine the code live. So we could actually just send you a snippet of code that fixes the problem, and then you could just basically telnet to a port and then paste that code in, and then your system will be updated live. And you don't have to take it down. So it could be while it's processing other stuff. It's pretty cool. I think that's part of the secret alien technology.
There was a slide coming up that actually articulates a use case where PuppetDB optimizes the whole process.
Oh, well, the use case is simple. If you're using store configs and you have more than 50 hosts, then use this. Actually, what I'll say the use case is, if you're using store configs at all, there's almost no reason to not use this.
Yeah.
Because it's faster, it's safer, it's, it generally takes a lot more care into making sure that the data is genuinely persistent, it stores a lot more information, and it's way easier to get your information back out of it if you need to. So at this point, other than the fact that it was just released yesterday, which is why it's 0.9 instead of a 1.0. But like I said, we've been using this internally to manage our own systems, and if those go down, we actually lose money. So that's so. I want to be intellectually honest and say it's not a 1.0 because I think it's dumb. The first release of anything ever, it's a 1.0. Use it. What could go wrong? But no, use it. Everyone should be using this. I don't see any real pressing reason to not use this at this point. Everyone should be using store configs to the point of some of the previous presenters. Everyone should be using it because it enables you to do things that you can't do if you don't have cross-node information. And there's tons of cross-node problems, in the world of system administration. So everybody should be using it, and the main reason why people don't use it is because it's slow. So if I fix the slow problem, you have no excuse to not use it anymore. Yes, sir.
So I don't know if you'll go into this later, but just something that as you're talking about PuppetDB, and not to bring up other projects, but one of the problems I run into a lot is it's not that you want to export a resource.
Yeah.
It's I want a list of all of the other servers that fit this, that are tagged this way or have this resource on them, so that I can build, use them in my templates instead of building a resource.
So you can query, you can make queries like that, which you can't do using the current store configs collection operator, the spaceship operator, won't let you express those things. However, the PuppetDB server will happily accept a properly formulated query that expresses those constraints. So you can actually query, you're not even limited by a single type. You could say, give me all the resources of any type that are tagged with this particular thing. So the missing glue there is a set of Puppet functions that would actually do that searching. And that's something that we're going to be coming out with real soon. Dan Bodie and some of the other people are working on that.
Well, in addition to Puppet functions, being able to use them in ERB, so that I'm building out, so your clustered example, I'm building out, a load balancer.
Absolutely,
I just want
accessible from ERB.
instead of having, because the standard way we do that in Puppet now is you export the file and you use a .d directory. Well,
and then you have an exec that collects all of them, and that's Yes, so I appreciate
works.
that. And so yeah, the functions that'll be coming out soon will work with that. You can access them via ERB. But yeah, even outside of Puppet, I mean, you could access this stuff with curl, which I'll show you in a little bit. Okay, and by the way, this is a good. I think there's already a ticket out there for this, but one of the feature requests people had is being able to, a change to the Puppet language itself to allow the current store configs, the current spaceship operator to take more interesting comparisons, more interesting operators, do stuff across types. But that requires a change to the language. So, it's a little bigger of a change. But I think that's a perfectly reasonable feature. I think we already have a ticket in there.
And to a large degree, from a platform point of view, this is an enabling technology. Now we can say store configs is usable everywhere. It's easier to build solutions on store configs that we don't have to say, well, what do we do about the 90% of the world who don't run store configs? We can say, it's there, we can enable these capabilities. We have something that is intelligently fast enough, we can assume that thin store configs store less information is no longer relevant. You have all the data, not just a subset. So it's very much an enabling technology for those very reasonable desires that were very hard to satisfy in the past.
So let's see. So the actual PuppetDB server, like I mentioned, this is the way the box looks. If you want, and I recommend this, is to not use. So it actually ships with an embedded database if you want to use it. That's mostly for ease of setup or proof of concept. Turns out, I mean, if you have enough RAM, it actually works perfectly fine for up to, maybe, I think I tried it on my laptop with it, simulating a couple of hundred hosts, like 200 hosts. I don't know, give it like a couple of gigs of RAM, 2 gigs of RAM. But you don't have to set up a separate database. It's fully persistent. Every single feature that PuppetDB supports works on the embedded database if you choose to use it. My personal recommendation, though, is for like real production use. Just use an external database.
So what sort of database is this one? Internal database server or like?
What's the question? Sorry.
Is it MySQL database server? Or you have
So the embedded database is actually one it's called HSQLDB, but it runs in process. So you can't like open up a SQL console to it or anything like that because it's embedded. But that's kind of the point, is like for people that don't want to dick around with having a separate database, like I just want to try this out, like, it's perfectly fine. For external databases, currently we support Postgres. We don't support MySQL for a couple of legitimate reasons. Number one is it has pretty poor support for array types, which we actually need because Puppet parameter values can be arrays of things. So that's actually a pretty important feature that we need to have. Number two is it doesn't support recursive queries. That's part of the SQL 92 standard. Almost every other database supports this, but unfortunately MySQL does not. And that actually allows you to do things like graph traversal in a really fast way using a SQL database. Like a lot of people are like, well, why would you store a graph in a database? Because then you got to make like 15 queries. And I'm like, no, you don't. Because if you were around in 1992 when that feature was implemented in the SQL standard, like that's what it's for. I mean, those queries aren't fun to write, but they're super fast to execute. And in some of the testing that Daniel and I did with test data sets with about 30,000 hosts, and I think something like 28 million resources, using a recursive query, I can get from like stage main, which is the root of all resources in your population, to every single leaf node in like 400 milliseconds on this laptop. So technology is good. But that said, I mean, you can, what we did internally is it was just like apt-get install Postgres. You edit the Postgres config file to create a new user to talk to PuppetDB, and that's it. You just hook the two of them together. He didn't even change the default memory usage or anything.
So I'm going to ask this now because you just pointed it out, and this drives me absolutely insane with things like Dashboard. There's a module that Puppet Labs supports on the Forge so that I can just download it right and go apply, class PuppetDB DB server exists now. Because like Dashboard, there's not, like there are people that have put them up, they aren't, they're like way complicated. I just want to be able to like use Puppet to configure Puppet.
Yep. So, there is, actually we posted the announcement and like within 3 hours, Alessandro, who's a longtime PuppetCamp and Puppet contributor, he put up a module that's on GitHub that you can use. The actual installation process is pretty easy. There's actually just 2 packages, and we build OS packages if you're using any, reasonably popular, Linux distro or something like that, where you need one package that sets up the server, you have one package you install on your Puppet Master, and there's 2 configuration files that you need to edit. And if you don't use the inventory service, there's a single config file that's 3 lines long. So the reason why I didn't write a module is I was like, well, it's basically just a file. It's a file stanza. But I'll send her one anyway. The other problem is, the reason why we don't have full automation for setting this up in Puppet is because of the chicken and egg problem. Setting up a PuppetDB server is ironically one of the exact use cases for store configs. Because I have the PuppetDB server and I have the master that needs to talk to it, but I need to exchange information between the 2 of them, like what's the name and the port of the PuppetDB server, and vice versa.
And the answer to that question is that even when you build out a Puppet Master, you use Puppet Apply to do the initial install.
Yes, yeah. So that is certainly a totally reasonable. It's a reasonable request. It is a perfectly reasonable request, and it's something that I would expect very soon to be a Puppet Labs sponsored module as opposed to a community module, like something that we support and we just publish. So that is coming. I will also accept hashes. I will totally merge in code for that. Probably not a whole lot. The last configuration variant you can do is for like truly epically bizarro, gigantic setups. You can actually, instead of terminating SSL inside of the server, you can actually use reverse proxy or something like that if you want. I'm actually not convinced that's entirely necessary, because honestly these days, like, dealing with SSL represents like so little CPU on a modern system. But if you want, you can toss up an Nginx instance or something like that. Figure's worth it. Okay, so unfortunately, it's not like a super exciting thing to see run. But I do have an instance of it running on my laptop. PuppetDB actually ships with its own benchmarking suite. So here, I'm going to be running my benchmark. Here's the config file. You can't see the rest of this, but there are other options on the tail end to basically say how many hosts I want to simulate, and what the simulated run interval is, and what percentage of the time do I want to randomize part of that catalog, which is meant to simulate someone actually logging in and changing the config of the system. So I have it set to be 3,000 hosts with a 5% randomization factor, which I think is actually pretty high, because I don't think it's 5% of 3,000 a lot. I don't know. And I doubt people are making that many changes in a day. You know what I mean? So anyway, that's going to submit some catalogs. You're going to see this information. Part of the reason why this looks sort of weird and cryptic is every command that gets submitted has a UUID. The reason why we do that is because in the logs of the Puppet Master, again, this is a distributed system, and I do this for my own laziness. If the Puppet Master has a problem, like submitting something to the server, or if it gets an error or something like that, there's a unique token that lets you correlate in time exactly the operation from the Puppet Master and the operation on the PuppetDB server. So that way you could use like grep and figure stuff out. Instead of having to do a bunch of dumbass like, well, this time, and but the time is wrong on this system, it's in a different time zone, like everybody's had to deal with that, and I hate it.
So it's the message ID.
Yeah, exactly. A lot of this, is very similar to like how email systems work, but people never think about how reliable an email system is, right? Like you just kind of assume if I send, cat pictures to someone that it's eventually going to get there.
And there's a Puppet module for NT.
And there is. Hope you guys like hilarious joke emails, because I'm taking all your addresses and sending them to you. So some notable improvements let's make over the current stuff that we have is, I think it is much more reliable than current store configs. We work really hard to persist everything that we accept. I already talked about all the automatic retry that we do. I already talked about the UUIDs. Anytime the Puppet Master talks to the PuppetDB server, that's all done using the same certificate, authority, and SSL infrastructure Puppet already has, so that's all secured. We have all kinds of checksumming to make sure that the catalog you send or the facts you send is unperturbed during transit. Like I already mentioned, we do all kinds of queuing, and we always have the dead letter office. We expose a lot of APIs, and like I mentioned earlier, we have this philosophy where we don't want to cheat. Like we don't want to offer any features in commercial products or even other open source products that require like a patch to Puppet in order to make this work. So all of PuppetDB works with a stock Puppet 2.7.12 or better installation. It uses all the built-in extension points, built-in ways of configuring things. You don't have to do anything extra. And basically anything that Puppet does, the Puppet Master does, when it talks to PuppetDB, you can do not using Puppet. So you can hit every single API endpoint. You know, if you want to write a script that submits a brand new catalog you just made up or typed it out, like you can. You can submit your own facts. You can write your own crazy queries that the Puppet language doesn't support. And all of that is eminently possible and supported. For an example, let's say that I want to get a particular set of metrics about how fast PuppetDB is running. So I can say that I want to get, for my command processing stuff, I want to get processing time for all commands, catalogs, facts, whatever the hell it is. And then I get a JSON dump. This is just JSON. That's curl, by the way. This is just JSON for all the internal metrics that we compute for that one counter. 50th percentile is probably what you want. But that's basically like, this is how fast we're going. That's something that's just available to you. It's all documented, all the metrics that we have, what their return values are going to be. If I want to get information about, I want to find all the facts for a particular node, you can just curl. If I want to do a particular resource query, like give me everything tagged with, some arbitrary thing, you can just hit a particular URL, pass it a URL encoded. Unfortunately, it's a curl limitation more than anything else. A URL encoded version of the query string. And how to formulate that query string is also documented and versioned. And we obey semantic versioning for that too. So we're putting a 1.0 version of all these like wire formats and stuff, and that's going to work as long as we support 1.0. And if we make a breaking change, then that'll be a 2.0 version of things. It's reasonably transparent. For example, going to work. 1 second while we let it actually download the statistics. We ship with a real-time dashboard that actually tells you a lot of different aspects of like what it's doing under the hood. You have information about how much memory you're using, the size of the queue, how many seconds per command. So how long does it take to store catalogs and facts and all that kind of stuff. These are all 50 percentile. So that's like, okay, 200 milliseconds. That's pretty good for that benchmark that I just launched a couple of seconds ago. And that's basically simulating 3,000 hosts with a catalog that has about 1,000 resources in it, which is a lot. I mean, 1,000 resources these days is kind of a lot of information.
So I'd love to torment you. Can you just shut down your database for a minute? Or is that the embedded one?
I can. I don't know what's going to happen there. Actually, I do know what's going to happen. Oh no. Let me see. I think that's running detached somewhere.
Huh.
I guess I could kill it.
Yeah.
Anyway, alright, I'm not going to mess with that. Spoiler alert, what'll happen is it'll basically just block all requests while they're waiting for the database to come back up.
So the queue depth will just rise, and when it comes back, back down to 0.
And because... So this is all done, this is just JavaScript and SVG. Because it's SVG, I'm going to be like, enhance. And I lose no, fidelity. Works on an iPad. Freaking mobile browser now does SVG. How crazy is that? The age we live in. Truly a marvel. So anyway, there's all kinds of other information here. Some of the other interesting metrics, I have that many nodes, I have approximately this many resources that I'm storing. This is running on my laptop, by the way. Because I'm using the same catalog for all the nodes, modular randomization, that's why resources duplication set to 100. And I'll talk about catalog duplication in a little bit. But anyway, we go to great lengths to actually make that information transparent to you. So anyway, like I said, we don't cheat. Every single data point that was displayed on there, you can get via API. So there's nothing magical about like that dashboard or anything like that, for what that's worth. And it's also, but that makes it easy to integrate with monitoring systems, for example. Like if you want to send a Nagios alert whenever your queue depth goes beyond a certain amount, which is a totally sensible thing to do, that's reasonably easy. So I'm going to go real quick through, and I've claimed that it's faster. That's not important. What's important is how that actually happens. So there's a couple of interesting design decisions that I think we made that kind of made a lot of this possible. I posit that your hosts are not all unique and beautiful snowflakes. So by that I mean if you have an infrastructure of like 100 machines, it's seriously, I just refuse to believe that literally all 100 machines have like completely different configurations. You're not running 100 different operating systems with 100 different shells or anything like that.
Challenge accepted.
Spaceman could probably do it, I'm pretty sure. So if that is true, therefore, a resource will often exist across multiple hosts, which sort of naturally follows, right? Like if not every host is completely unique, then you have some resources that are the same across several hosts, which leads to a feature that is single instancing of storing the resources. So we actually do a lot of deduplication inside of PuppetDB, so that even if you have like 30,000 hosts, if they all have the same like 1 million resources, then that's actually really, really cheap and fast to do, because we need to store all 1 million of them once, and then for all the other bajillion hosts that we get, we never actually have to store any of that information. It's a little tricky because we had to do some work in order to make it fast, but essentially as we get resources in, we compute unique hashes for every single one of them, and then we basically compute all those hashes for the entire catalog, and we use bulk operations, which are reasonably fast. So instead of doing like 1 million queries or something like that, we can send a single bulk operation, do set intersection and things like that in order to figure out what resources do I actually need to store, and that cuts down on a lot of the work that you need to do. So if you have the same user account that exists across like 10,000 hosts, that only gets stored once with like 10,000 really tiny pointers. That turns out to be really simple. For those of you that use Git and wonder why that's so fast, is it does the exact same kind of thing under the hood with stuff like hard links. And we're basically implementing links kind of in the database for that kind of stuff. So this is not rocket science, but it does work. It's a pretty significant speed improvement. So internal to Puppet Labs, on the dashboard, we had a metric, which was how many resources are duplicated across your entire environment. So we see 83%. So 83% of all of our systems are identical, which kind of makes sense, right? It's all the same user accounts, the same like NTP config, DNS, all that stuff is mostly the same across everything, which means that I'm now doing 83% less work when it comes to storing resources, which is a big savings. Posit. The Puppet runs frequently, every 30 minutes or something like that, but your catalogs probably change infrequently. So like I said, if I have 1,800 hosts with a run interval of 30 minutes, that's one host checking in every second. But I'm not sitting at my Puppet Master, like editing my .pp files, like literally with one edit every second. Like I'm not doing that. I probably push out, well, I don't know. On average, how many changes are you guys pushing out per day using Puppet?
Average?
Sure.
Probably zero.
Zero, exactly, right? But that's kind of the idea, right? Is you're not constantly dicking around with all of your systems because, I mean, if you're going to, do it through Puppet, but you probably shouldn't be doing that so much. Yeah, but not like 1,000 changes per day.
Oh, no.
Or anything like that. Even, Nigel Kirsten, who was working at Google running all of their Mac operations, that was all managed through Puppet. And in talking with him, he was like, yeah, we would push out like 5 changes a day to everything, to like tens of thousands of machines, right? So it's not a huge deal. Therefore, we will often receive, overwhelmingly often, the exact same catalog for the same host every time that it runs, which leads to a feature of single instancing catalog storage. This follows the exact same principle. We can compute a unique hash for the catalog. And again, this is actually similar to how Git does it. It's the Wikipedia article is called an oracle tree. But basically, it's just a tree of hashes. So if the one at the top matches the one that you've already stored, then you don't actually need to compute anything down below. That's like a real quick check. And then it lets you say, oh, you know what? I don't need to do any work. So if you run PuppetDB in practice and you have like 1,000 hosts, performance will be like, not bad. It'll be much faster than current store configs, but it'll be like a certain rate until each of those 1,000 hosts has had one of their catalogs stored. And then what you'll see is it'll just like the time it takes to store something takes a nosedive because it doesn't have to do any work. Because every 30 minutes when something checks in again, it sends the exact same catalog. I don't have to do anything. So stuff can actually drop down to really, really low. And at Puppet Labs, 88% of the time, when we get a catalog, it's the same as one we already have stored. So again, you take those two together, that's like a huge amount of work that we're not doing. You have more than one core, those store configs is single-threaded. If an agent checks into the Puppet Master, that Puppet Master, there's one like process allocated to handling that. I mean, I guess it depends on what web server you use, but for the most part, Ruby limits this. You have basically one process doing all this work. So while that thing is waiting for stuff to be stored in the database, or while it's waiting on a query response, it can't do anything else. So one of the big things we wanted to do is avoid that, because if that's the case, your throughput is not maximized, because you've got a lot of time when your cores are spent not really doing anything, which leads to a feature of massively parallel operation. I don't know if you can see it. Oh, I don't think you can, but let me try. Bringing up the activity monitor. Whoa. Let's see. CPU history. So this is my laptop running PuppetDB, and I'm using a lot of cores, pretty much. But again, I'm simulating, sending like I'm basically simulating a population of 3,000 very complicated hosts. But anyway, the point I wanted to make is that if you have, it's a laptop, right? My laptop has that many cores in it. My phone has more than one core. Like all software should be using more than one core, man. All right, I'm off my soapbox now. So what PuppetDB does is it can basically pat its head and rub its tummy at the exact same time. Nothing really blocks any other operations. So I can be talking to the database while at the same time accepting stuff on the MQ, while at the same time receiving query requests over HTTP, which at the same time I'm computing hashes for stuff, or I'm running a real-time metrics dashboard, and I can do all of that. There's not a single explicit lock in any of our code, so for the developers out there, that might be of note. I won't talk about it a whole lot, but it's actually not written in Ruby. It's actually written in a variant of Lisp called Closure. The reason why we did that is because we don't have to do any locks. It basically does automatic concurrency management for you by having kind of an in-memory database. So you know how like people used to write stuff in C, I mean a lot of people still write stuff in C, but then garbage collection came around and that kind of frees up your brain to not have to do like malloc and free and stuff like that. In a very real sense, this language kind of does the exact same thing, but for parallel operations. So I don't have to deal with locks anymore, because the system kind of takes care of like ordering operations for me. And so far, since we've been running it in PuppetLabs.land, we've never had a single race condition or deadlock on anything. And I'm not smart enough to build it, I'm just smart enough to use it. I know when I see a good thing, I guess, so. All this stuff is not like, it's not rocket science. It's just building, it's like a couple of very sensible optimizations like kind of put together, built on what I think are somewhat sensible technology choices where if you have them working in harmony, it ends up with a system that's pretty fast. The future, there's a couple of things that I would like us to do. Number one is, like I mentioned before, doing things like report storage, I think would be nice. Having PuppetDB have more of the information stored would actually be pretty cool. But there's other things that we can do. Like we have, did that actually animate? Probably not. So this is an example of visualization of a catalog that we have. What you can't see that's happening off screen is that we have a text box where it's like, I'm searching for group, and then it highlights all the things that are groups. Or I want to search for service, and it will highlight all the things that are services. Or I want to search for user accounts, and this highlights the section of the graph that is related to user accounts. I think this idea is really powerful. So someone asked earlier, like some of the different ways in which we can, like, more easily visualize this information. And I think being able to present people information like this is powerful. It lets people say, like, the way I describe it is, you know how if you do a lot of work in a knock or you're racking and stacking gear, like if you looked at the rack next to you from some company and all the cables coming out of it are just like this, tangle of spaghetti and it just looks terrible, you're like, wow, those people really don't have their act together. It's like, use some cable ties, seriously. The problem is that for software, or for managing your infrastructure through software, like I really think that in the back of our minds there's kind of this intuitive idea that, if our virtual like cables were laid out nicely, if everything was tied off really nicely, or more importantly, if I showed you a graph of something where everything was like connected to everything else and it looks all crazy, it's easy to look at that and make a qualitative judgment like, you know what? Like, maybe dependencies aren't expressed correctly. Or maybe if one thing fails, then everything is going to be affected. But if you have something like this where areas of responsibility are clearly demarcated, it's like, all right, I don't know. I think that's kind of a pretty picture. But I think the reason why the picture is pretty is because our operations guys at Puppet Labs do a really good job of maintaining their Puppet code, refactoring their Puppet code, making it look good. And I don't know. I mean, I think one of the things I lose working on ones and zeros and semicolons a lot is that it's hard to see the forest through the trees. And this is the forest. And I think if the forest looks pretty, it's probably not a bad indication that you're doing a good job. I think, in a lot of ways.
That is real data there from our infrastructure.
Yes, this
isn't
is
it?
actually one of our hosts. I believe this is one of our Debian package building boxes, I think. Everybody in the company has a user account, and we actually use store configs and things like that to populate it, which is why you see this big leaf of stuff like that. I should have had a graph from one of the other hosts. We use fail to ban to keep people from logging in, if they've failed logins a certain amount of time, and every host collects fail to ban information from every other host. So that ends up with you have a little line and then just a cluster of super connected, buckyball or whatever that molecule is. Anyway, just thought I would toss that out there. It's free, it's open source, pull requests are definitely accepted. We already merged one, someone found one 40 minutes after we announced it. And I was like, ooh, on the one hand, that's great, on the other hand, it kind of sucked. But yes, clone it, and like I said, if you're using store configs, definitely download it and play with it. You can ping me on IRC if you're having any kind of problem. I'm in the business of making sure that works. It's actually reasonably well documented. If you go there, we have installation instructions for both Puppet Enterprise and for the open source version, how to get it installed, how to get it configured. We have all the specs for every single wire format. Everything is available. And yeah, like I said, just use it and tell me about it. Because I want to know. If it's too slow for you, I want to know. So I can make it not that. If you wish that you had a different way of querying the information that's in there, I want to know. Because that is my mandate, is to enable that. And the first cut of features is based on the current ways in which Puppet gives you to query that stuff. But that's not everything, right? So I'm kind of relying on users to actually tell me, what sucks is that I can't get this information easily. But you're storing it. I just can't get at it. That's a problem I can solve, and it wouldn't be that hard, I don't think. Maybe. And that's it. That's all I got. Anybody has any questions? There were a lot of them during the talk, but.
For the back-end Postgres database, I don't know if anybody asked about, do you have any kind of an HA configuration for that, or?
Not that we ship by default. What we used internally was basically, there are modules on the Forge that do it, but it's sort of how you want to set up HA, I guess, is something that...
Or do you have a reference, a blueprint, hey, here's how to...
We
You
don't...
got a concern about that.
Yeah, we don't have one. I guess I never thought about it mostly because it's sort of the database people have a bajillion guides on how to do HA for any particular database you pick, but we probably should make recommendations and at least point at them. For Postgres install, there's hot standby if you want. You can do warm standby if you don't care about having that kind of uptime. And one thing I will mention though is at the end of the day, if you lose all of the data inside of PuppetDB, if you just wait. If your run interval is 30 minutes, just wait 30 minutes, and it'll just get repopulated from all your data. Which is why I haven't really cared a whole lot about. Yeah. So, and if you don't want anybody to react on,
the other processes would stop, right? Since you decouple.
That's right.
Yeah, absolutely.
The facts and the catalog.
Yep. So the easy thing to do would be trigger a Puppet dry run across every single host, and that way it's not doing anything destructive based on incomplete information or something like that, and it fully repopulates the database with literally everything that you need. So, problem solved. I guess. And if you want to get the list, never mind. I was going to say if you want to get the list of hosts that you need to run this on, you could query this, but if it's down, that really isn't going to help you. So, chicken and egg. Anything else?
You were talking about if the database dies, just wait half an hour. But if you have actual Puppet running, that the Nagios server hits it first, it gets incomplete data, or it gets
if the database is down, then that Nagios server, when it says to the Puppet Master, give me my catalog so that I can run, the Puppet Master will actually say, I can't give you a catalog, man, because the source of information I need to give you that catalog is not there. Okay, so your agents will actually, will fail. But I think that's kind of what you want them to fail.
And it's... You were saying though it's just wait half an hour, the data will be
yeah.
back.
So that's why you need to do a dry run if you want that. If you want it to be repopulated with absolutely no possible consequences, The other option is, I mean, yeah, the first time the Nagios server checks in, it will get, you know, maybe only the 3 other hosts that have had their catalogs persisted by that point in time. But the next time it runs, you know, assuming the run interval, you know, is correct, the next time it collects all that information. So, like, this actually happened internal to Puppet Labs, where they rolled something out and they, you know, pointed it at a completely different database, and then our Nagios server actually just started to, like, spam everybody with everything. Actually, all the checks got just deprovisioned from Nagios, but then, like, 20 minutes later, they came back up. That's not great, but we didn't lose any data. Part of the benefit of having this stuff in Puppet is that you can always rebuild what you have based on the model that you've written in Puppet, right? So, you know, this is mostly about like safeguarding the infrastructure from like partial data scenarios. Yeah. But yes, sir.
So you still need revision control for your manifest, basically.
Yes. Yes. Highly recommended.
Money is
yeah. The problem though, I mean, it's a lossy operation. Like the catalog we get, I can't reconstruct your source code from the catalog, right? In the same way that I can't like reconstruct a WAV file from an MP3. I could reconstruct a degraded version of that, you know, but it's not going to be identical, right? So your manifest basically that's the Bible for your whole infrastructure.
And so you can turn object code into C code,
yeah.
But you won't have all the if def
yeah,
stuff.
yeah. If you disassemble anything, for any of the people that tried to break copy protection on games in the 90s, like me, you don't want to get that stupid cardboard wheel to play SimCity. But like, no, I mean, your Puppet code really represents, I mean, that's like the way you want your whole infrastructure to look. You know, so you should treat that as important as that sounds. You know, which is like, don't have a .back directory. Like, don't do that, man. Just like put it in version control, ship it off to another server.
That is the stuff you put in your bank vault, so that when you sign a contract saying you can recover if a meteor hits the office, you really can.
Maybe not your data, but you know, those credit cards practically pay themselves off. Anything else? I'll be at the pub. Talk my ear off.
Yeah, hold on. So thank you. Round of applause for Deepak.